Okay, so we have talked about complex numbers before, right?
Yes.
So what do you know about complex numbers?
Complex numbers are broken up into the part that contains the number I.
Okay, and what is I?
I is the square root of -1.
We can think of I as being the square root of -1.
Yeah.
Or another thing that's going to sound the same, but is just a slightly different way of thinking about it. You can think of it as being a number so that when you square it, you get -1. So I is a number that has a single property. And that single property that it has is when you square it, you get -1.
Yep.
Okay.
Okay. Now, why don't numbers that we usually call real numbers, why don't those numbers have that property that you could square one of those numbers and get -1?
Because
Usually-
the square root, when you square it, it always becomes a positive number, because when you multiply two negative numbers together,
Huh?
you get a positive number. If you multiply two positive numbers together, you still get a positive number.
Okay, so what are the possible numbers that we can get by squaring real numbers?
Positive real numbers or 0.
Okay,
Not negative numbers.
but not negative numbers. So I is a number that is a new number, and it solves this particular difficulty that we don't have any numbers that when you square them you get -1.
But it's not a real number.
Right, it's not a real number in that this is what she was saying, why imaginary number might be kind of a bad name for this number.
Yeah.
It's not any different than like the number pi or e or even the number 5. Those numbers all have particular properties.
Mm-hmm.
This one just happens to have a property that seems a little unusual. You can't have a number of apples equal to I.
Yeah.
I don't think. It's not a counting number. But I don't think you can have a number of apples equal to pi either.
Unless you
No.
cut it really finely.
Well, how fine would you have to cut it?
Infinitely correctly.
Yeah, right. So there's no such thing as apple pie.
There is.
Oh, there is? Oh, okay. Well, there's no such thing as a pi number of apples.
Yeah.
All right, and then, so how do we normally write complex numbers out when we use the number I?
So you write them in the real number part, like call it A.
Okay.
A plus some number B times I.
Okay.
So A plus BI.
All right, and then if I want to multiply, let's say I want to square this number, a plus bi times a plus bi. Do you know what you do here?
It's just like squaring a normal polynomial.
Okay.
You just multiply the a through, and then
All right.
this term through.
So I get a times a, which is a squared.
Plus,
What do we do next?
multiply the a to the bi.
Plus a times bi.
You multiply the bi to the a.
And now here we'll use the commutative property that b times a is the same as a times b. So I'll call this plus another a times bi.
And the bi times bi
And what does that
is
produce?
minus b squared.
Okay, how come?
So I squared is -1, and b squared is just b squared.
All right, so I get b squared times I squared, which becomes minus b squared. So I get a real part, a squared minus b squared. And what's my imaginary part? Can you tell me?
It is the ABI.
And how many of them do I have?
2 ABI.
So the imaginary part is
2 ABI.
2ABI. Yeah, very good. So with complex numbers, we can just treat them as if they seem to have all the properties that real numbers have. We can multiply them, we can add them. But then, here's the real surprise with complex numbers, is they have really amazing geometry. All right, so let's take a look at that.